Right, test. Hello, test. Testing, 1, 2. Test, hello. Can you guys hear me? Alright. Hi, so I'm here to give you all some food for thought. So basically, if you haven't really realized, it's already week 7, right? Week 7. So time is really very fast. I think a while back, you all were just sitting here listening to the seniors talk. So my question for you all today, you all should start thinking about it, is what you want to do this summer. Summer of code. Summer. So start thinking about it. I'm sure some of you have not think about it, but some of you have. So some of you might go, okay, I want to bump, or I want to go and travel. So like these are not like bad things to do, but then I'll change the question to what meaningful activity you want to do this summer. So maybe you might say bump very meaningful, so we can disagree on that. Okay, so some options are, keeping in line with the exam mood. So A, community service. B, special term. C, internship or work. So who wants A? Nobody. Who wants B? Also nobody. Who wants C? Okay, not bad. So the rest want to bump. Okay, never mind. What about D? Who wants D? So obviously D is the reason I'm here. Okay, so I'm from Competing for Voluntary Welfare Organizations, or CVW, and I'm John, and over there is Wangsha, the comeback girl. Yeah. Okay. So mission 1, not your GFDI mission 1, is the first mission of our organization. So we develop IT systems for voluntary welfare organizations. So it seems that we are just like a vendor, but actually no, we are there to help improve their workflow. So it's like we're trying to solve their problems and help them do their work better, because their work is very important to society, and a lot of times they are not doing it the best. They are just using their own practices, so which might not be the best way to do it. So let's go back to the question. I will review the answer. So community service. How are we doing community service? So maybe I can share one of the stories from past years. No, sorry, wrong. I will first share the organization I work with. So we don't find those random organizations. All these are names, big names in Singapore. So notable ones are like YMCA, Minds for the intellectually disabled. CA is one of the biggest community services in Singapore, in the heartlands. And then you have Methodist Welfare Service, Pertapis, and Geylang Home for the Aged, and Lions Befrienders. So now I'll share one of the stories of how exactly we improve workflow. Because improve workflow sounds very, very, very fluffy. But let me show you what we actually did. So this is Geylang Home for the Aged. Basically, when they check in, last time they'll put their IC down there. So why they need to check in? Because you need to take attendance. Basically, what the business of this places is to ensure that the old people have things to do. So just in case anything happens to them, people will know and to keep them active. So after we went in to build the system, so now they have a scanning system, and they don't have to take attendance anymore. So it seems very simple, but the thing is, it makes a difference because these organizations submit things called reports. So they need to know today how many people use the massage chair, today how many people sing karaoke. Yeah. So special term. So people who typically want to do special term, why do you do special term? I'm assuming you want to learn, and of course you want to clear your MCs, right? So don't worry, CVW has another mission, which is not just to help, which is the teaching component. So as you know, this person here likes to teach. Yeah. So even though he's actually a scholar, but he decided teaching is more important, so he came over to NUS. So fourth, then at least for the this year he will be teaching you all. So it's not just about programming, because I don't know whether Prof has mentioned about coding is supposed to be very simple. So it's all the other problems that are hard. So yeah. And then he likes to teach this thing called common sense, which he finds not very common among students, which is true, honestly. So you might be very good at writing your compiler, your Lisp program for a compiler, but that doesn't mean you have common sense. I'm not saying anything about that guy. I don't know who that is anyway. Yeah. So because when you deal with actual clients, you cannot just talk to them using code. They won't understand your code. They will talk to you in their code. So you have to decipher it. Furthermore, when you talk about MCs, we're actually giving you knowledge from existing modules. So you learn a new programming language, development platform, which is PHP and MySQL in a framework. You do that in cs1102, which is database. You have to do project management. Even though you're not the project leader, you are in the group, so you see how the project leader manages. You do specification work with real clients, which is all part of cs1103, except cs1103 is in classroom environment, and you get to pretty much come up with the software that you want. So that's not really specifications. They can only tell you what specification is. So you also will learn how VWs work in Singapore. Every time you go and do CIP, all you do is go there, be the peons, but actually how the VW is run. And then you are forced to have the skills which IS2101 teach you. They teach you to write report, teach you to write meeting minutes, all those things. Yeah, you do in class, very fun, but there's a real purpose behind it. So lastly, is obviously internship and work because you are doing work. Alright? So let me go through again how CVW gives you all the above. So firstly, you actually contribute to society. I think it's important. I don't know whether you think so. You do learning from inside and outside the classroom, because we also do a bit of training. There's allowance of $3,000 or $2,000. It's not a lot, by the way, but at least it's allowance for you. Make sure you can have food to eat, you can travel, so on and so forth. Working experience and module credit. So it's 4 MCs of SU or graded, depending on your performance. So obviously it sounds very good, but there's no free lunch. Prof Ben, you have taken 111S. You know how hard you have to work. So CVW is no different. Yeah. So if you don't believe me, how's some random dude talking here? Listen to someone more wise, i.e. your chief tutor. So yeah, just read. I don't read for you. So Zihan was alumni batch, right? First batch, right, Prof? Second batch. Yeah, and he did. I think Prof always says he did the best job so far. Okay, so I don't take too much time because you all have to do the leave early because of U-Town thing. Yeah, so if you want more information, you can come down next Wednesday, 6:30 to 8:30 at meeting room 1. It's at Com 1, the 3rd floor. Right, are we booking there?
Book already.
Yeah, okay. So before I go, I leave you with some words. So like I said, it's really very fast. So uni passes you in a flash. So you should make the best out of university life, whether you are here by choice or not. Alright. Yeah, join CW. Meeting room 1, Com 1, 3rd floor. 5th floor? 3rd floor, not 5th floor. Okay? Yeah, join CW. Yeah, that's what I was going to say today. Okay.
I think that's it. Okay, thank you very much. Okay, thanks John and Angsha. Alright, so now we go back to the actual class thing. Alright, okay, first of all, let me just quickly sound so you are here. Ryan, come down, thank you very much. See you, bye-bye. Okay, so one quick thing about the exam. As I said to some of those of you who came earlier, I'm sorry I couldn't finish grading today because Thursday I was a chauffeur. So I had to chauffeur my advisor who's in town, up and down. So I tried that, I couldn't finish. Really passing scheme in my head is not so simple, and I couldn't pass so many. So I'm halfway, I finished first 3 questions, I'm halfway through question 4. Question 4 requires quite a lot of parsing. Okay, you are quite creative in the ways you are trying to solve it, so I need some more time to parse it. So far the results are very good. The top guy is 98, second guy is 5 so far, not about half graded. Several guys in the 80s. So clearly people know what they're doing. We also have a few disaster cases. But let me just quickly explain to you the whole point. Question 1 is really about understanding how to infer specifications. Okay, so you also, aren't you glad you have to do cons and car and CUDA? Fun, right? Alright, then obviously different questions test you on different parts of the different concepts that you're supposed to know. The last question of this, last sub-question of this question has no answer, obviously, in case you don't know already, you know. So, moral of the story is that not everything has an answer, and sometimes, you know, life's hard, right? Last thing, then question 2 is really, first sub-questions are giveaway questions. In case you don't know, it's supposed to be giveaway. Then the last 2 parts of question 2 are supposed to be to figure out whether you can do pattern matching. Right? And then the Q3 is about using data types. So basically, we're giving you a new 3-box cons essentially. Okay? And we basically, you know, tell you can move the pointers around. Right? And the general point here is also to see whether you understand how to actually manipulate the references. Because when you create the linked list from the list, right, you need to return the reference to the first piece of that is not quite so trivial. I mean, it can be done, but figuring out how to do it requires some amount of thinking. Alright, obviously some people figure it out. Those who haven't figured it out will figure it out. Alright, and the last question has to do with signal processing. So essentially, your extraction of the columns is a mapping operation. Okay, so if you figure it out, it's very simple, right? 3 lines, 4 lines, finish. Don't figure out, my God, then I suffer. Okay, so so basically, if you suffer, I suffer, right? So you all have a very simple answer that's obvious to me. Then, if you have this random stuff you write, then I suffer as well. So there's some karma involved. Okay, and obviously the last question is wishful thinking. You need to figure out at a high level how to solve the problem, and then obviously you need to break out into parts. Right? Any questions? No, right? Okay. So first of all, I think most did quite okay well. The small number of people who kind of combusted, there is hope for you. Right now, the tutors are in the midst of preparing a re-examination, which means that you get to, those people who do poorly will get to resit the exam. Obviously, if you resit the exam, the grades is capped at 60. That means basically, so this is how it works. I think we are now in the process of figuring this out. But tutors are in the process of basically setting a paper, submit a paper, have no time. And what happens is that those people who do worse than 60 can come and take again. Okay, it'll be a full length, 1 hour, 45-minute paper. Obviously, maximum grade is 100. But no matter how well you do, if you do better than 60, you'll be kept at 60. If you do worse than 60, then obviously you will get the new grade you get. Or whichever. Okay, if you do worse than the first one, then obviously I let you keep the first grade. Okay, it shouldn't be the case. If you get invited to this, you know, party and then you do worse than the first one, then I think something is wrong, right? Okay, so the point here is basically give you guys a chance to. Okay, those the 98 guys, please don't come. Thank you very much. The 2 guys 98, 95, please don't come for this re-exam. Thank you very much. Okay, Hey, you may have mark for fun, right? So the point now is this is basically, I haven't looked at the final distribution yet, but I suspect something like 70 in this, in the midterm will be an A. I mean, you get 70, you're like in the A range. Okay, 95, those guys, 80s and 95s, obviously in the A plus range. If you're in the 60s, you're sort of in the B plus, B range. And below 60, then you have, look at the chat. Alright. So the moral story is this, this class is meant to level all you up, right? And if you all screw it up and do badly, then it affects poorly on me, right? Alright. So obviously, you know, my job here is not to basically grade you, but to make sure that, you know, step everybody, make sure you all, you know, get across the bar and actually figure out how this is done. Any questions? Alright, another thing is this, the 95, 98 guy, I don't know who the heck you are. We'll probably match up. Another thing that we do in this class is that at this point we'll know who are basically in trouble and who really have the whole, you know, 11S in their pocket. So what we do at this point is that we'll match up the guys who actually do very well with the people who seem to be struggling a little bit. And hopefully we can help them, the ones who are like 98, 95 can help the ones who are weaker, who have figured it out, you know, do better. Okay, so we try to do this, you know, the commando thing, right? You know, Basically, if someone on a stretcher, then you all carry together. Yeah, how fun is that? Okay, so hopefully, I hope to see every single student do well. Okay, at this point, I think it's diagnostic. If you don't do well in the midterm, it probably means that you haven't quite figured something out that you ought to know by now. Alright, so sadly, you have to work harder. Questions? So when Wangsha said, don't worry, he didn't mean don't worry. I think you worry, but the point is that you just know that it is possible to catch up with hard work, but effort has to be made. Okay, and you cannot be doing the exam by trying to remember, past year questions and what the solutions are. That is a complete disaster. Questions? Okay, if not, thank you very much. So this is a short lecture because typically I return scripts and nobody pays attention anyway. Alright, so but good news, there's another award we won, so an achievement to be unlocked. So if by Sunday there's a midterm survey that's appeared in the IVLE. Okay, those of you who quite complete the survey by Sunday will give you this achievement. This achievement looks very cool. What the heck is it? Sunny Cloud, right? This achievement is called forgiveness. Okay. Basically, this achievements which are like don't know how many streak, right? Like 12 streaker, like 12 or don't know 8 streak, right? So normally people will do 7 and they screw up the 8th one. So very sad. So what can this do? This achievement basically you can actually use it, okay, to basically ignore one of the missions so that you can complete your streak. Make sense to you? No use, okay, whatever. But anyway. So this achievement, okay, if you don't use it, at least it's cool on your achievement box. Right, so quite finish it for me. We will give you a new achievement by Sunday. Alright, so today is a short lecture to basically, one thing is to revise what we have. Okay, by now, essentially you must know all these concepts, right? Basically recursion iteration. Okay, obviously, most of you know both, one or both, right? Then order of growth, the exam is really simple. There's one person who got it wrong. I'm like, oh god. So far one person, there's a question 2B, right? Okay, there's so far one person who got this thing wrong. So I remember distinctly because there's one. Okay, which is not so great. Alright, but order of growth by now you should know. Okay, and fast flip is the one whereby you halve the index. Okay, higher procedures, obviously you have seen quite a lot of it in question 2. Okay. General idea is to basically you have to look at patterns and also know how higher procedures work and to do the mapping. Okay. Next, data abstraction. Okay, so we have done some of that already. And how many of you went for the theory lecture yesterday? Only 3. Okay. Anyway, we will probably be putting it online. Hopefully you all can watch it so you all can understand the history behind abstract data types. Okay, which means what? Which means that there are objects, okay, which pretty much hide the details. You must interact with the state only through operations, right? That's what we discussed last time. So list processing, trees, okay, and symbolic data we didn't do a whole lot, but then in the midterms, the last question you're dealing with symbols, okay. Equality, you must understand the difference between EQ and equal. All right. Generic operations essentially is what we covered last before the midterm break. Okay, and I think you are doing a lot of this, number 2, data-directed programming in the missions, 13 to 16, right? 12 to 15. Okay, so any questions so far? Okay, so now today we will do more of message passing, and rest station next week we will talk more about how to do this. Okay, now so far our computation is functional. Okay, so what that means is that given the same arguments, you always have the same results. Okay, let me show you an example. Okay, sorry, before that, they're also memoryless. Basically, each function call or procedure call is independent of the past, alright, and of the future. Okay, so this is how cool because it makes it easy to reason about programs, right? So yeah, so this is a nice thing about function programming, typically memoryless. Okay, so factorial 5 always gives 20. Okay. But not true, right? Suppose you have a bank account and I tell you that it has got $100 inside. And then you do this withdrawal procedure. Okay, you report the balance if there's enough money. Okay, if not, then it makes this error. So for example, you do with 25, you get 75 left. Okay, and so forth. Okay, so this is how you sort of expect the bank account to work. Essentially, you must kind of check how much is balance, okay, and basically if it's not enough money, you must freak out, okay, otherwise we just reduce the number, okay. So this is different from what we're used to, right? Because what this shows you now is that you can procedure, okay, where the result is actually different, even though the arguments may be the same. Okay, so this bank account obviously has memory, okay, and it will remember how much money you draw. Okay, if it's zero, then you can't spend money. Okay, so this is called state. Right. So as Barbara said yesterday, right, it turns out that in real life programming, what we care about is modifying state, right? You don't compute factorial for typically nobody really does computing factorial for a living, because it's not very useful. Okay, so typically what you need to do is to work with state. So this is why this is important. So it turns out that function programming doesn't allow our programs to have state because it doesn't allow you to do this thing called assignment. Okay, so let us show you what's assignment. All right, so now this is where the assignment appears. Okay, so let's look at how we would implement what you saw earlier. So we have this thing called withdraw balance. Okay, lambda amount. Okay, so what happens here is that if you do make withdraw balance, means you create a new account, okay, for which you tell it how much money it has left, right? Okay, and lambda amount, why? Because the resulting account is a procedure. You apply an amount to it, and what you do in the amount, if the balance, okay, is more than the amount, okay, you do this set balance minus balance amount. What does it mean? You basically reduce balance, right, by the amount that you specify, and then the return is the last thing, which is the balance. Otherwise, you no money. Okay, so W1 is we withdraw 100. Okay, we withdraw $50. $50, very simple. This one, you have an error because why? Only $50, right? You can't withdraw for 60. So if you do 40, it's 10. Okay, so this is a simple idea. Okay, so look at set bank. So set bank obviously is a still form. Okay, I say again, as mentioned before, but let me just say this again. The bank, the exclamation mark is called bank. Okay, is actually a kind of notation to tell you that it was going to mutate the argument. It means whatever thing that is being put inside, right, it's going to change. Okay, so here, what you have is the format is that you have name and new value. Okay, so name obviously is a symbol, just like your define. Okay, and this name here is obviously not evaluated, and this part is evaluated, and then you basically assign it. Okay, so name is symbol, not evaluated. Okay, you evaluate this part and you assign it to the name. Then from now on, the name will evaluate to new value. Okay. Okay, balance 100. Okay, it's 100 now. Okay. Now we set bank balance to minus balance 20. Okay, obviously it's 80. Okay, and you can keep doing this. So the question is, what is the difference between define and set bank? Okay, so obviously now it looks the same, right? When we set bank and define. Okay. Now, it turns out I don't answer this question now. Okay, you just keep this question in mind and just try to figure out along the way whether you can figure out what is the difference. But obviously there's a difference. If there's no difference, then we don't bother, right? The fact that there's a set bank and define tells you that it looks a little bit different and odd. Okay. So it turns out I can't really explain this to you in this slide yet. Okay. So you just keep this question in mind. Okay. Now let's look at another example. So now what I have is I've got two new variables, W1, W2, right? Both of them start off with $100, okay? And look at this sequence. It's obviously like that, right? Okay, it's quite clear that this is how it works. There are two accounts, you know, you withdraw money differently and then you get different amounts. So obviously in this case it's quite clear, right? That these two objects are separate and independent, okay? And each of them has their own state, okay, which is balance. Okay, and obviously withdrawals don't affect each other, okay. You will be quite freaked out if David and then Bart, his accounts, starts to depleting, right? Then you're like, wow, what's going on? It's still called CBS. So obviously in life you need to make sure that that these things actually are independent. Okay, so let's take a look. How could you do this, right? So one thing I can do now is that I can do this thing called make account balance. Okay, the earlier part I've already shown you. Okay, earlier what happens is this. Earlier, we only could do what? Drop money, which is kind of sad, right? Okay, so now we decide to basically enhance your account, account plus, where you can actually put in money, right? So what happens now is that we create an account called balance, okay? And then interestingly, we create these two procedures, right? The withdraw amount. If the balance is more than the amount, we will change the balance. Okay, we'll reduce the amount, the balance by the amount. On the other hand, if you do deposit, what you will do is that you will actually increase the balance by the amount, right? Now what happens after this? We will define this procedure dispatch. Okay, make account balance. Okay, inside here we define two procedures. Okay, withdraw and deposit. It's obvious what it does, right? It just changes the amount. Now, then I define a procedure called dispatch. Okay, and this dispatch does two things, right? It takes an argument M. What is M? It's a message, okay. So essentially, it takes an argument called M, which is a message. Then it's withdraw, or it can be deposit. So what I do, if it's withdraw, I return the procedure withdraw. If it's deposit, I return the procedure deposit. Otherwise, I freak out and say, sorry, I don't know what this is about. Yes? What does the begin for, is it? Because if can only take one line, your if consequent, right, you can only do one thing. So in order to do multiple things, you need to actually have a begin. Now what happens is you're doing something, and you're returning the return value will be the balance left. Okay? Because you need to change the state, right? I mean the account, you need to basically okay. So set bank does what? Set bank changes the value of balance to a new value. Right? Of course you want to account whereby you draw money, you open up account still $100. You draw money, open up still $100. But sadly, this doesn't happen in life, Yeah, this okay. If you work in a bank, that's the problem. A good question. So you work in a bank, this is the kind of duck you want to introduce in your own account, right? But sadly, typically it doesn't happen that way. Okay? And the point here I'm trying to make is this. The point I'm trying to make is that now, what I'm showing you here is an example of the method 3. Right? Okay, so remember there are 3 ways of doing this during operations. First one is this dispatch on type, which is really the simple if-else check statement. The second version is what? Data-directed programming, where you put stuff in the table, which you do a lot in missions 12 to 15. So by now hopefully you know what's going on. So now I'm showing you an example of method 3, which is this thing called message passing. So the value of this object is this procedure called dispatch. And how it works is that you give a message to the object to tell it what operation you want to do, and it returns you the operation. Right? So this is like a lookup table, except it's embedded inside the object itself. Okay. Now, so if you do ACC, this is how it works obviously. If you do ACC, make ACC, and then you put $100 inside, you can do ACC, and you put in the message withdraw, and then it returns you a withdraw procedure. You apply this procedure to 50, you have 50 left. Alright. Similarly, you can try the 60 and then you realize not enough money. And you can put back some money, okay, and you can withdraw money there. Okay, so this is how it would work. Questions, David? Diagram is symbols, what do you think? You can use anything you want, use strings, you use strings, use numbers, but obviously you should do it some way which makes sense, right? Okay, maybe in the exam I give you one of these things so you can use other things. Okay? Alright, so ACC is a dispatch procedure, okay, it's actually a dispatch, right? And it calls to it will be through these messages, okay? And this is again, I said before, message passing style. Okay? Now if we do ACC2, make account 100, this will create a separate and independent account. Okay. So assignment is cool because it allows us to create object to state, which is absolutely important because that's what people care about in life. Okay. And interesting, you can actually have objects behave differently over time, which is sadly what is also often needed. Okay, and this thing is this. I mean, once you have this ability to do assignments, you can then model real life objects, because it turns out that most real life objects are not immutable. Okay, so this is the general idea. Okay, and in fact, you definitely need this mechanism for real operations. Okay, because this is how it is. Now, what's so bad about this? Why did we do this earlier? Okay, there's a reason. Because obviously this thing makes life complicated. So the question will be, okay, now that you have these objects, that kind of changing over time. So when are two objects the same? And what do you mean by change? Okay. And then this also makes it harder to reason about programs. So if you have immutable things, objects, you can actually do static analysis and basically figure out a program works all the time quite easily. When things start changing, it's a lot harder, not impossible, but harder to verify correctness. Okay, and the thing that it turns out is that, okay, we taught you this thing called the revised substitution model, right? To evaluate this scheme procedures. It turns out that substitution no longer works. Okay, and we'll be talking about environment model next Wednesday. But let me just show you why it works, why it doesn't work. So this is the procedure you saw, right? Make, withdraw, balance. Okay. Now, so okay, I mean, we taught you RSM. So obviously you do RSM on this, right? This is a basic thing you try to do. Now, okay. Now what RSM says is this, right? Remember? Okay, RSM has the following form, right? This is the procedure. One argument. Okay, obviously it's the x inside the mouse, right? So you do what? You take 25, you substitute into the body as 25, right? Okay, so do this. So this is what you get, right? So this is the thing to evaluate. First of all, what I'm saying is this: with withdrawal 25, this is equivalent to this, right? This is just rewriting the procedure in full. Okay. Now, how do you apply lambda amount on 20? You take 20, and in the case, you take 20, you put this into amount, and then you place inside, right, all the things. So this happens. Now the problem here is that balance is not evaluated because it's a special form. Okay, so in the end you will return 25. Right. Okay. So the point here is that the old method of evaluating an expression by just taking the argument, okay, figuring out how you map the argument onto the parameters, and then substituting everything, doesn't work anymore. Okay, it will give you the wrong result, because here what happens is that you need to evaluate balance first, and then you return balance, right? So you will then you return the balance, right? Okay. So let's take a look. Okay, basically the problem is this: the RSM considers a variable, okay, as just a name for a value, and therefore it can be substituted for each other. But this only is true if in the operations that you perform, that these objects don't change, right? So where this fails is because what happens is that as you are evaluating the expressions, right, some variable has actually changed. So at the beginning, balance is different from at the end. Okay, so the difference is that assignment considers a variable and not so much as a name for value. It's actually considered, it's like a container. Okay, so this is a very subtle point, but this is why it breaks down. Okay, so we will need a new model to do this, to understand how this works. We will talk about this next Wednesday. Okay, and it's more sophisticated, and it's called the environment model. Okay, and again, this is a bit complicated. You will see next week why it's complicated. But just know that this is why it fails. Okay, let's look at this problem of sameness and change. Now, suppose Peter and Paul both have an account with $100 in it. Okay, what does it mean? Are you sure? Okay. So anyway, well, this could be it, right? This is David's world, right? Okay. It turns out there could be a more progressive world, right? Okay. Whoever said Peter and Paul cannot share account, right? So as we have, a world, a society is more progressive, It could be that these two guys, you know, share an account, right? Okay, so this could be, so the problem here is that with this definition, it could be either or of these two values, right? Okay, so what is the difference? Yeah, so in the first case, actually there are two people, each with different bank accounts. Okay, that means they have actually $200 between them. Okay, in the second case, actually the two fellas are actually sharing this bank account. Okay, probably for good reasons. Okay, and the thing is that this is distinct. Okay, and obviously here, if you make changes to one account, it won't affect the other one. Okay, now this case, obviously, the Peter and the Paul accounts, they are the same account. So essentially, you actually have a joint account. So drawing or putting money into one of them will also affect the other guy. Okay, so now this is an interesting idea, which is called aliasing. When two variables, two names are assigned to the same object. Okay, this is called aliasing. Now this makes life very hard. Okay, because the problem here is that it makes it very hard to reason about this correctness, because now things are changing and it's very hard to figure out prima facie what's going to happen. Okay, so this makes life very complicated. And if you want to mutate one of the accounts, we have to be aware that you will also possibly affect the other account. Right. So this is the question. And then you will find shortly enough that once you start mutation, life is a lot harder. Okay, because things are changing. And if the problem is complicated enough, okay, changing one thing will affect other things that you can't really see, and then when it blows up, then you realize it's there. Okay? So, okay, let's look at an example. So this is obviously your favorite thing called FIB, right? You can probably write this in 5, 7, 10 ways. Probably infinitely many ways, right? That's part of the problem with my midterm exam. Too many ways really. So, this is one way of doing it, right? Well, the reason why you do it is this, right? Because you know that how you do FIB later is when you do A, replace with A plus B, okay? And then B is replaced with A, right? Questions? No problem, right? I mean, this is old stuff. I mean, this is from week 2 or week 3. I can't remember. Okay, but this is old stuff. You're all clear? Any questions? It's very simple. This is what you get. Now, well, in Java or some imperative, so this is obviously functional style. By now, this should be your bread and butter. You can do it in your sleep. So now with set bank, we will try to do we'll try to do scheme pretending to be C. Okay, so this is what you call scheme pretending to be C, right? Okay, this thing is called loop, right? Okay, in case you don't know. Okay, so I've defined this thing called iter. Okay, and then n is n, whatever, and there's a and b. A is 1, b is 0. Okay, you do iter, and then I check whether n is 0. Okay, if n is 0, I return b. Okay, otherwise I do what? I follow this rule, right? A is equals to a plus b, and then b is equals to a. Okay, and then I reduce the counter by 1, right? I call myself, right? It's okay to do this because after a while, you know the n will reduce to 0, right? And then you return ub. How cool is that, right? So this is known as the scheme pretend to be C. Okay, and this thing is called a for loop, right? Okay, how cool is that? Okay, who likes this? Hey, I am telling you this rule works, right? Correct? I'm following the rule. What? How hard is that? Okay, so okay, this is this and this. Okay, and okay, this is a while loop. Sorry. Okay, questions? So it's that what is this? This is while n is more than 0, do this, right? So how? Okay, obviously it doesn't work, right? Why not? Because what happens here is that I've clobbered A, right? I set A to A plus B, and what I've done is I've clobbered A, right? So A doesn't exist anymore. So now I set B becomes A plus B, actually. So instead of doing what? A becomes A plus B, B, very good, very clever. So you change order, done it, right? So you flip them, then A and B will be flipped. It's okay, then now you'll be fine, right? Yeah, so sadly, now it's still wrong, because now the A becomes A plus A. So So the moral story is that this is the way to deal with this problem, whereby you need to define extra variable, okay, to basically remember the fella before you start clobbering stuff, okay. No. So this is not very hard lah. Okay, this is really quite straightforward . But the thing to highlight is this I have these rules which are obviously correct. Alright, because the last time you saw it, A plus B replaces A replaces A plus B, and then B replaces A, obviously correct. Okay, but it turns out that if you just mindlessly just do this thing, will blows up royally. So this tells you that essentially mutation is not so straightforward. I mean, there's some complexities. Okay, so the main challenge is this in imperative programming. Okay, where you have mutation, the order of the assignment sadly is very important. Okay, so you must figure out what you're assigning in what order, and also remember that once you assign something, you have clobbered the old value. It's a little delicate. Okay, and this obviously tells you why it's really complicated. Okay, so it turns out, however, the fact is that you can't use assignment alone to solve problems. There are instances I've shown you earlier whereby you actually need to create a temp variable to store something temporarily so that you can swap things. Okay, essentially this is a problem. Essentially you have two things essentially if you have two things, okay, you need to swap them. There's no other way than to create another thing to move this one here, copy first, move this one here, and move it inside. You can't just swap because you overwrite. Okay, that's the key general idea. Okay, so today, like I said, it's only a short lecture because you need to go off to U-Town. The general thing I want to introduce to you is this idea of state, okay, which you've sort of seen. Okay, in question 3, right? Question 3, I have shown you a glimpse of what's to come, right? Where I let you have these cons boxes. Essentially, there are just 3. Okay, what you saw in question 3 for the double linked list is really what? It's really the 3-box cons, right? Okay, whereby you have 2 pointers on both sides and you have one thing in the center. And the other thing I've shown you is that you can start changing the pointers, which makes sense, right? Okay, so this is what really is happening. You have now changing of state, okay, which is sometimes values, sometimes pointers. Okay, and assignment is what allows us to create state. And the key thing to understand is that the RSM will break down. Means you can no longer look at the program and evaluate what it does by just substitution. Okay, pretty much that's all I have today. Okay, now so let me remind you. First thing is that okay, do my midterm survey and you get your the new forgiveness achievement. Very cool. Second thing is this. Okay, the midterm exam I will finish grading by this weekend. I will finish grading. Okay, see, I need a half left, half of question 4 to pass. Okay, those of you who did well, good for you. Those who didn't do so well, like I said, not to worry. Okay, basically you have your chance to redeem yourself. Okay, at the two ways. First thing is this: you have essentially a re-exam. Okay, in about 2 weeks. Once we figure out the exam, we set a timing. You do that. This one will allow you to bring your grade up to 60. Second thing, practical exam will have 3 questions, which are your standard questions. Okay, and there will be 1 extra, like, bonus questions. Bonus, okay, and essentially the excess points you get in the midterm exam, okay, in the practical exam, can be brought forward to your midterm exam. Cool, right? Reason is very simple. See, the whole point of this class is not about how well you do. The question is, have you actually learned the stuff that you are supposed to learn? Okay, practical exam is where you show me that you can actually write programs to solve problems. Okay. Now, if you can write programs to solve all, the point is this: the practical exam will be 30 points max. Okay, wrong. It means the maximum grade you can get from practical exam is 30 points, but there will be 50 points worth of questions. How cool is that? Hey, then up to 20 points can bring forward to midterm exam. No, wow. Okay. Sorry, cannot. Okay. So it is the 2 jokers who are 98 and 95 are confirmed. They will be going to final exam with 100% CA1 almost. Okay, but it happens every year. And then midterm, then final is where they fight it out. Okay, so it's very fun. So it means the 98, 95 guys will probably, the 98 guy will probably get 2 points, at least 2 points. Okay, hard will not get 2 points. The 95 guy probably will get extra 5 points. So all this will all go to the final exam with full CA. Then they'll fight it out in the final exam. Okay, this is how it works. What? The rest of you can catch up, okay? So are there any questions? Alright, details forthcoming, so don't be too worried. I will grade the midterm exam, okay, and I will also update the solutions. There are some typos, unfortunately. Sorry, I try my best. But I'll upgrade, I will basically add some extra solutions from some of the creative things you all put in. Some bad things you all do, I may also put in, okay. And I do this because the key of midterm exam is to learn stuff, okay. So hopefully you all will spend some effort. I noticed that not everybody went to check out the midterm solution so far. Hopefully after I update the solutions and revise it, you all will check it. Any last questions? Alright, okay, very good. I'll see you guys next week. Thank you very much.